G'day guys, and welcome to Circuits with Ty. Today we're going to be learning about a little something known as Kirchhoff's current law, or KCL for short. Now, believe it or not, Kirchhoff's current law was invented by this guy right here, Gustav Kirchhoff, back in 1845 at the ripe old age of 21. Now before we go any further with that, the first thing you're going to need to know is what actually is current. Current is basically just the flow of electrons through a closed circuit, kind of like the way water flows through a pipe. The next thing we need to know is what a node is. A node is just an intersection in the circuit where the wires meet up. So now we'll look at an example of a node here. We've got the source current, I1, flowing into the node, and coming out of it are I2, I3 and I4. So what Kirchhoff's current law says is that the sum of currents going into the node is equal to the sum of currents coming out of the node, which is shown here by the formula I1 equals I2 plus I3 plus I4. Now when you take into account the fact that the direction of the currents makes it positive or negative, we get this little thing here that says the sum of currents around a junction, around the node, is equal to 0. So look at an example of that. We've got a basic circuit set up here. Power source, we got our two resistors, and so we know the current leading into this node here that we're analysing is 10 amps. We know the current coming out here through resistor 2 is 6 amps. We need to calculate the current through resistor 1 here. So we use the same equation as before, go I1 plus I2 plus I3. Rearrange that to get I2 by itself, substitute in our values, and then we have ourselves an answer. I2 equals 4 amps. Alright, thanks for tuning in guys, see you later.